terms under linear momentum. Okay? So, thank you so much, guys. Okay, let's do this fast. Okay, first we need to discuss, elastic collision. Actually, these are all momentum, right? Two types of momentum. Okay? Oh my gosh. Two types of momentum. First is elastic collision. Okay, like that. And then we have also the inelastic pollution. So we have also the perfectly inelastic pollution, in which most of our examples following that. But there's no such perfectly inelastic pollution in the real world. They're perfectly inelastic pollution. Okay. The word here is elastic, meaning undergoing the process of elasticity. Okay. Or the ability to be stretched or to bounce back and forth. That is elasticity, to stretch a certain material and then to be bouncing back and forth. So this is the elasticity. Okay? Like that. So two types of linear momentum, the elastic collision and the inelastic collision. Okay? Something, but both are linear momentum. Okay? So this is going to be following the formula of P is equals to the mass and the change in velocity. So this is the formula of the momentum. Okay? So what is our example for this? So we need to consider first the elastic collision, right? Okay, I don't have to erase this one first. Okay, so if you said elastic collision, it's gonna be for example, if you do the billiard, okay, and then you like that, right? So the first ball will run to be physically conducted to the another ball, okay? Meaning the other ball is at rest, and then only the one other ball will be moving. So that is under elastic collision. Okay? So for example, this is your first ball with a mass 1, and you have another ball with a mass 2, something like that. Doesn't matter the mass of each ball. And then, so this is your, for example, you need to say before hitting and after hitting, or equivalent as saying before collision and after collision, something like that. It's gonna be like here and okay. So before collision and after collision, or before hitting and after hitting. So L1, we have a corresponding V1 and will go here to strike the M2. So it's going to be M1 with corresponding velocity initial V1. Okay? It's going to be like that. Ito po yung mga palangga. So this V2 here is resting. So the initial velocity of F2 is 0. Okay? So it's resting. And then it will become like this. It will be moving like there or moving there. Like that. Okay, at the point mga palangga. So, what will go to the top and what will go to the downside? So, hello. What will go to the top? Okay, basically the M2 because it is being pushed, right? So, M2. And then what's going near the downside will be the M1. So, after hitting the mass 2 of the second ball, we have the final velocity of the mass 1 and the mass 2. At the point. So this is going to be having our V2 asterisk, or should we say V2F. So our V1 asterisk or our V1F. The final velocity of the first ball and final velocity of the second ball. Okay, ganon. So in here, since this situation is elastic collision, we need to say both the momentum and the kinetic energy is conserved. Okay, take note 3. Okay, both kinetic energy and momentum is conserved. Okay, is conserved like that. The point, so there will be no losses of the energy. Okay, if you mean both kinetic energy and the momentum are being conserved, meaning to say there's no loss of energy in this process. Okay, with the point. So how can you compute for the formulas? First, okay, for elastic collision, we have 3 versions of formula. Okay, first, we have, okay, first mga palangga, we have, hi Miss Rivera, shout out. We have the momentum conserved equation. This is for elastic, ha? Momentum conserved equation. So we have mass 1 times the velocity 1. Okay, something like that. You get the point mga palangga, and then it's gonna be producing mass 1 with the velocity of the mass 1 final. Okay, final velocity of the mass 1 meaning V1 asterisk or V1F. It's also okay because on you plus M2 times V2 asterisk. Okay, you eliminate the V2 here because the other ball is starting from rest. So when you multiply the final velocity of the second ball, which is 0, so it's also 0. That's why you don't have to put here. Actually, it is plus M2 V2. And the V2 is 0 on shot, so automatically 0. So this is the equation. Okay? Like that. And then second version is the energy conserved equation. Okay, so it's gonna be, since kinetic energy, the formula of kinetic energy is equal to 1/2 times the mass times the velocity, all you have to do is to add 1/2. So 1/2 times mass 1 V1 is equal to 1/2 mass 1 final velocity of the mass 1, okay, plus 1/2 times mass 2 final velocity of the 2, or the ball 2, or object 2, something like that, okay? So it's gonna be the conserved. And now, after the third equation will be the head-on collision, meaning it will be heated. The mass of the other ball, the first ball will hit the other ball. So there will be a head-on collision. Okay, so head-on collision of the target ball or the other object will be equation. Head-on collision will be equal to, so how can we do this? So we need to compute for the V2 final. Okay, so I already showed you the schematic diagram. So when the first ball hit the other ball, so that would mean the mass of the first ball and the second ball will be equal because they will be contacted with each other. Get the point? Get the point mga palangga? It's gonna be twice of the mass 1. Okay? Get the point? Ano siya? Mass 1 plus mass 1. Okay, twice of the mass 1. So it's gonna be like that. So 2 times the mass 1 over M1 plus M2 times V1. Okay, you get the point? V1. Okay, mga palangga. You get the point? Okay, wag man tayo V2 diri ari sa equation. V1 lang ang siya. You get the point? And then your another version of the final velocity of your mass 1 will be like this. Mass 1 minus mass 2 divided, okay, ano siya? Dito po ano siya may tabo? Okay, is equal to mass 1 plus mass 2. Okay? Dito po ano siya may tabo, guys? So mass 1 minus mass 2 equals to M1 plus M2 times another here is V1 1. Okay? To the point. So if you try to compute here, it will be just the same here. Here. Okay? Like that. To the point, kung mapalala ang mitad, mabutas sa kung kape mapalala ang mitad, it's gonna be like that. Okay? Get the point, ano na siya, mabutas sa kung mapalala o coffee. Ganon. So, muna siya formula. Final velocity of the second object or second ball will be 2 times mass 1 over m1 plus m2 times v1. And v1, final velocity v1 is m1 minus m2 over m1 plus m2 times v1. Natumuan na siyang bola. So, muna siya. Now, for the second one is the inelastic pollution. In inelastic pollution, guys, only the momentum is conserved, meaning the kinetic energy will be converted into heat, okay, and energy, or shall we say a sound, okay? For example, if you threw this eraser to the wall, like that, okay, so it will create a sound, and then the eraser will be coming hot a little bit because of the impact of being contacted with the other object, something like that. But the example here is two balls are striking with each other. Okay? So here's the first ball, M1, like this, M2, second ball, and then they will meet with each other here. Okay? So when they meet with each other here, okay, so they stick together, okay, they stick together and they will share the same velocity. They will share the same final velocity. Did the point? So the ball 1, ball 2, ganon. So they will share the same velocity already when they stick together. So this is inelastic collision momentum. Okay? Like that. So the movement could either be going there, or either be going here, something like that. It depends on the surface, or the roughness of the surface, or shall we say, which among them is having a higher mass. Okay, if the other having a higher mass will go there or there. It depends on the situation. If you apply force also, more force, even though that is a very less mass object, and then if you push them very hard, very strong, the two ball will be going there also. It depends on the situation, okay? But the point is they will stick together and share the same velocity. So our formula will be here, okay, momentum is conserved. Momentum is conserved, but the kinetic energy can be converted into heat and sound. Okay? So like that. With a point. So it's gonna be M1 V1 plus M2 V2 is equals to M1 plus M2 times the final velocity. So final velocity is equals to M1 V1 plus M2 V2 over Km1 plus M2. So this is your final velocity. Look, you have the same velocity after they contact with each other, stick together. So this is inelastic pollution. So this is the second type of, another type of momentum. Okay? So that we can understand where it's going on. So actually, I think as far as I can remember, when I took up the board examination, there are at least 3 problems for momentum in general engineering. Okay? In the general engineering, the first day of examination, so there's physics, linear momentum, but I think there's no angular momentum at the time. It really came out in the board examination. Okay? So I kumpiyansa sa momentum topic. With a point. Ganon. Okay? Hindi ko siya so far. Wala na no. Sa'yo naman siya. Okay? Binom sa coffee mga palangga. Shout out to Shen Elizabeth, Michelle Rivera. Thank you so much for listening to my lecture, physics lecture. Oh my gosh. Okay. Ganon. Ay, nakakalaw. Okay, for a while. Chart. Binom sa coffee guys. Would you put fairness? Trap! So after this, I'm gonna be having I'm gonna have my exercise and again, and that's for my cardiovascular exercise. Oh my gosh. Wow. Coffee without sugar. Okay, mga talaga. So, I'll be having an example later on. Thank you so much for listening to this lecture. Bye-bye.